A heat source at 10 raised to 3 Kelvin is connected to another heat reservoir at 10 raised to 2 Kelvin by a copper slab which is 1 meter thick. So let us draw the copper slab. So this is a copper slab. This copper slab is 1 meter thick. Given the thermal conductivity of copper is 0.1 watt per Kelvin per meter, the energy flux in it through the steady state is watt. So essentially we have been given the thickness of the copper slab. Let us say the thickness of the copper slab is known to us. This thickness happens to be T. T happens to be 1 meters. So this T is given to be 1 meters. Okay, so at one place or one side of the copper slab is the source, and the source has a temperature 10 raised to 3 Kelvin. At another side is the sink, and the sink has the temperature 10 raised to 2 Kelvin. Alright, so naturally heat is going to flow from the source to the sink in such a manner heat would try to flow. Now we are asked the energy flux, and we can see from the unit that they are asking essentially watt per meter square. That is essentially the unit of intensity, which is power per unit area. Now we know that dq by dt according to the law of thermal conduction is going to be equal to sigma, which is the conductivity of copper, A delta T or delta theta as it is called, the difference in temperature, divided by length. Now in this particular formula, length is given to be 1 meter. We have to find out 1 upon A dq by dt. Please note that we are supposed to find 1 upon A dq by dt. Also looking at the units of the answer, if some student is confused about what is the meaning of energy flux, then units of the answer are giving a very clear idea as to what has to be found out. So 1 upon A dq by dt is going to be equal to simply sigma delta theta. So delta theta happens to be equal to 10 raised to 3, which is 1000, minus 10 raised to 2, which is 100. So that is going to be 900. The value of delta theta is nothing but 900. And what is the value of sigma? It is 0.1. So this answer is going to be equal to 0.1 into 900. So the answer is going to be equal to 90 in the units that they have asked for, watt per meter square. So the answer simply is A.